Okay, hi everybody, and today we are going to talk about the properties of parallelograms. Um, as you may or may not be aware, parallelograms are everywhere in nature, in construction, in all sorts of the products that we buy, and so it's important to know some of the characteristics that we find in all types of parallelograms. I'm going to try to keep this video as brief as possible, so yay. First of all, we need to know what a parallelogram is. A parallelogram is simply a quadrilateral where both pairs of opposite sides are parallel. So there's a good picture right here. We've got this pair right here and this pair right here that are parallel. This pair right here, this pair right here that are parallel. Now this is all that is required for a parallelogram. So your parallelogram could look something like this. It could look like this. Oh, hey, I just found something new. Okay, but it could be a rectangle. It could look like the parallelogram I just drew. Or it could just be a square. Okay, all of these have both pairs of opposite sides parallel, and that's all that's required. Okay, something like this would not be a parallelogram, even though it's got the one side of the parallel lines. The other side is not parallel, so we just call that a trapezoid. Okay? Let's see what parallelograms can do. Theorem 8.3. Theorem 8.3 simply says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay? This is an unnamed theorem, and almost all of the rest of them for the chapter are going to be unnamed. We're just going to have to refer to them by number, okay? Which, as we all know, I am absolutely a huge fan of. Okay, so all that this one is saying that is that if you have a parallelogram, then not only are opposite sides parallel, but opposite sides are also congruent. So for our example here, if ABCD is a parallelogram, then we know that AB is parallel to DC. DA is parallel to CB, but that's not what I wanted to say. So I will put those back. And what I really want to have down is that AD is congruent to BC, and DC is congruent to AB. Okay, that's a pretty straightforward theorem. Let's see if we can get another one. Theorem 8.4, also unnamed. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So this is very similar to what we just talked about, but instead of having to say that this side here and this side here are congruent, and this side here and this side here are congruent. Now we're talking about angles. This one and opposite are congruent. This one here and its opposite must be congruent. Pretty straightforward. So if ABCD is a parallelogram, then angle A is, you know what, I'm just going to write this. I don't know what I did, but I screwed something up. Okay? If ABCD is a parallelogram, then angle A is congruent to angle C, and angle D is congruent to angle B. Let's move on. Theorem 8.5. If a quadrilateral is a parallelogram, then the consecutive angles are supplementary. Now this might be a little bit trickier to understand, but I think it would help if I did this. When we were doing special angle relationships, we knew that these angles right here, this one and this one, have a special name. These are consecutive interior angles. And they were the ones that were different. They were the ones that, instead of being congruent to one another when your two lines are parallel, they were the ones that were supplementary. So every parallelogram has these special lines built in. I can do it right here as well and call this line the transversal, and then you have x and y that are going to be supplementary. So all that this theorem is saying is that when you have a parallelogram, then any two consecutive angles are going to add up to 180. X and y here, or x and y here. They're both going to add up to 180. So if ABCD is a parallelogram, then x plus y, no matter which x and which y you're talking about here, are going to equal 180. Okay, let's keep moving. Example, ABCD is a parallelogram. It's got a whole bunch of missing information and a whole bunch of variables going on, and just the information that it is a parallelogram will allow us to find all four of the missing variables. Okay? And they give us a hint by telling us which order to find them in, but I am confident that you guys could do this on your own. Okay? Find W. Okay? So I actually have the next couple of slides are this worked out, so we're going to move on and do them one at a time. W right here, first of all, notice, just going to move this again. Okay. W, first of all, notice, is right here next to an angle that's 65. And what did we just learn? We learned that when you have two adjacent angles, okay, and you know in a parallelogram, then you know that they must be supplementary. So real quickly, we can say 65 plus W, maybe it's this one. No. Oh well. First thing we can say is that 65 plus W is equal to 180. Okay? And then that will allow us to solve for W by just subtracting 65, and we get that 115 is equal to W, and so we will label it right here. 115 degrees. Okay? Now we'll find X. Well, X over here is the side, and it is opposite to this side 12. What's one other thing we know about parallelograms? From theorem 8 point something something. I'll allow you to use your cheat sheet, obviously. We know that AB, nope, not the one I wanted, that's Y. I know that BC and AD, that is this line here and this line here, must be congruent. So we just simply say that x plus 5 here and the 12 right over here must be equal to each other. So x minus 5 equals 12. Add 5 to both sides. You get that x is 17. Okay? So we will write that in. X is 17, which makes 17 minus 5, 12. Okay? And now we're going to try to solve for y. There's one other thing that we know, and that's the other two sides are congruent as well. 2y and 9 must be equal to each other, so we set them equal to each other down here. AB is equal to DC, 2y equals 9, divide both sides by 2, and you get that y is 4.5. So once again, we will write in our missing information. 2y, y equals 4.5. And then there's only one other thing to do, and that is to find 5z here. Let's see if it's on the next slide. Yeah, there it is. Okay. We know that the opposite angles are congruent. 65 and 5z must be congruent to each other. Okay. So, very simple. What we will do is say that angle A must be congruent, or the measure of angle A must be equal to the measure of angle C. And so we get 5z is equal to 65. Divide by 5, divide by 5. Clearly this 5 should not be here. It should be over here. Okay, and we get that z is 13. And we've found all of the missing information just from the single fact that we have a parallelogram. So that's what's cool about parallelograms and all these theorems, is that with very little information, we can find anything we want to out about a parallelogram. Okay? And this was the one we did first. So I will move on. Yours, number 1, you should be able to find W, X, Y, and Z, given that D, E, F, G is a parallelogram. Theorem 8.6, we've got more. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Remember, bisect means, well, let's first go back to diagonals. Diagonals are lines that connect two non-adjacent vertices in a polygon. So A here and D are adjacent, and A and B here are adjacent. So those are not non-adjacent, those are adjacent. So the only diagonals we can really draw in a quadrilateral are across from each other, like that. Okay? And in a parallelogram, we know that these lines must bisect each other. That means cut each other in half. So this one right here will tell you that this one and this one must be the same. And then when we do the other diagonal, I'll just wait for the lines to erase. There we go. When we do this one, it must cut this and this in half. Okay? Making those two lines that I just labeled congruent to each other. So if ABCD is a parallelogram, then we know that AE must be congruent to EC, and we know that BE must be congruent to ED. That is to say that this must be congruent to this, and this must be congruent to that. Okay? Pretty simple, I think. Let's move on. Example. LMNP is a parallelogram. Find QN and MP. I will warn you, we need to be careful that we understand what the question is asking and not just assume that, oh, it's asking us to put a 4 there. Let me do this permanent. It's asking us to put a 4 there and a 6 there. I'm done. That's not actually what it's saying. It's saying find QN, which is this right here. So we did the first one because we know that as this box is hiding right here, we know that QN is equal to LQ. And so LQ equals 4. Therefore, QN equals 4. Perfect. But the other one is not asking us to find, as we might assume if we read it too quickly, to find QM. Instead, it's asking us to find MP. And that's this whole thing right over here. Okay? So we need to be very careful about that. As we've already started to do, we know that we know that MQ is congruent to QP, so we know that their lengths must be equal. So 6 equals 6 and 6. But when we try to find the whole thing, we have to add them up together. And the numbers here are completely wrong. So let's just ignore those. I apologize. I did this video very quickly, and I did not edit everything. So we know that MQ is equal to QP. So we know that, and then we know that MP is equal to MQ plus QP. Well, we already were given QP, so we can say that MP is equal to 2 times QP, because we know that this here and this here are the same, so we can just say, well, we've got one of those. If we just double it, we have both of them. So we have MP is equal to 2 times 6, which equals 12. And we're done. Okay, this one is yours. It asks you to find X, Y, and ER. Make sure you understand exactly what it's asking for carefully. Okay. In a parallelogram, we'll do this one together. The opposite sides are sometimes, always, or never parallel. Okay, well, one way we can do it is think about it. It's a parallelogram. So opposite sides are probably often parallel. But the other thing we can do is we can just go back to our definition from slide 1, or from slide 2. A parallelogram is a quadrilateral where both pairs of opposite sides are parallel. It doesn't leave any wiggle room. So, so we go back here, and it says a parallelogram is a shape where opposite sides are, it has to be always parallel. That is the only requirement that you need for a parallelogram, in fact. Yours number 3, good luck. Yours number 4, good luck. And I do believe we are done. Let's see, record time. Okay, enjoy everybody. I will see you tomorrow.